Oh, I'm streaming. Right. Okay, so yeah, let's open up a terminal. Let's move it around to make sure that everything is working. Okay, good. CD BumperCoins bot get status. Wait, let me make sure I didn't leak anything important. No, I didn't. Okay, good. Let me just close this. Okay, so anyways, actually let me just wiggle this around to make sure that that my camera's capturing this input from the screen capture. All right, let's okay, so let's just yeah, let's just like look at our last commit. Untested work on symmetries for policy transformations. Hopefully symmetry is finished. So this is what I did last time. Let me like look at my last TSC commit. Yeah, so like I ran this command to verify that like no errors were thrown. So this compiled successfully. So that means I think we're on the verge of being done actually. So in fact, let me go to Connect 4 actually. Get status, because I know I made some changes here, right? Get diff. Okay, so this one right here, what I'm going to do is I'm just going to just like physically just copy this whole line, right? Copy this whole line. Then let's kind of reset it to the origin. Or just a little quick get stash. Get stash. Okay, so then get status. So now everything is clean. I was gonna reset it hard to origin main, but yeah, so we just kind of stashed it. So connect 4 is up to synchronized, is the same as the remote, as the origin. So that means what we want to do now is like to actually train it, right? To actually like train the neural network, what we need is train.ts. And train.ts runs self-play, which uses Monte Carlo tree search, which is mcts.ts. So what we want to do now is copy Monte Carlo tree search onto our BumperCoins bot. And then we also want to copy, sorry about that, Control A. We want to also copy, what do you call that? Train.ts. Train.ts. .ts to BumperCoins. And I think that's it, right? Like bot, bot, forget that. Yeah, game, forget that. Yeah, so this stuff. Yeah, I'm just like skimming through all this output. And I think that like more or less like the actual training code is just these two files, I think. So that should be it. Okay, get status. Let's just do a quick get add all. Get status. So right now, if we run this, there should be an error when we do apply move. Like right now, apply move with MCTS, like the MCTS which we have copied over, only applies the move like with the move. But then we also have to pass in the game state to link to it. Or actually, yeah, let's just actually edit MCTS and bring this change back there. Yeah, let me just kind of copy this line again. Copy that. Actually, no, let me just copy this to be specific. Just the extra input, like telling it to like, cause like we basically like took the node.game state and we cloned it so that like we have a new thing where changes to this, when we apply the move on this next game state, our changes are not going to like mess up the actual game state that we cloned. Like that's why we deep clone it, so that like so that we're not going to mutate any of node.game state. We're not going to dirty it. It's going to remain pristine. So then what we want to do is we want to also like create a back pointer to it, because as a prev game state, once we apply the move, we get like a next, we advance it, but we need to maintain a pointer to the previous one. So okay, so this is like, yeah, so I copied that. Let me just do a double check. Let me just copy one more time. Okay, and now let's open up mcts.ts and search for apply move right here, like in this line. So then what we want to do here is just paste it right there, right, just like that, right? What is going on? Did I just create a new file called v? Oh, I created a new file called v by accident. That's so stupid of me. Oh, does Vim not like create a new file if you just quit out of it? It doesn't create the new file. You have to actually write some stuff in it, I guess. Okay, anyway, so now let's like look at our git diff. So yeah, all we did right here is we just kind of added that. So in fact, one thing we could do, oh, never mind. So yeah, this is like exactly the same thing there where we just kind of added the game state. Okay, so now let's check if this actually compiles, right? Let's check if this code compiles. What do we want to check if it compiles? Train.ts, because that's like the entry point. That's the actual like what does the training. Okay, line 58. Oh, I see. So the same thing here. Let me think. So okay, let's take it from the start. Let's take it from the top. We have our initial game state, and then it's ongoing. So then we like do MCTS, and we get a policy, and then what we need to do is we kind of clone everything for good measure. We just kind of build up our examples. Of course, at the end, we're going to do the assign the rewards, like based on win or loss, if there was a decisive thing. So then we get the move. And now when we do apply move, we're now like messing up the, we're now like, yeah, this is kind of like damaging the game state, right? Like there's a reason we cloned it in the examples, right? Like we're actually mutating the game state. So what we need now is to actually, like, sure, it's fair enough. Like, absolutely, like this game state, let's let the significance of this variable, this game state, like this local variable in the self-play function, self-play game function, this local variable game state, what it must do, its responsibility is to store like there's like an implicit current game state. So this is the actual like current game state in the self-play. So then, and that's fine. We're allowed to mutate it. But then when we're pointing to something, we don't want what we're pointing to be mutated either. In fact, we're not pointing to anything. The games at all times, the game states previous will be undefined. Like we're never actually assigning. That's why we have to like actually put something in here to assign. So then what I think we have to do is rather than apply move rather than apply move like what do we back point to? We should again, like just like we did for Monte Carlo tree search, we have to clone it and only then apply move. And then the second thing is like that thing dot clone or whatever, right? Oh wait, no, what am I saying? Sorry, it's actually the reverse. It's still a clone, but like in Monte Carlo tree search, we're invoking dot apply move on the cloned object, the next game state, which is like game state dot clone. But here we're actually applying move on the actual game state. So then we have to put a clone somewhere, right? Like clearly. So then we're just gonna have to like clone it like right in the argument as a second argument, like this. Game state dot clone. We just add that, right? Game state dot clone, just like that. That's what I believe, right? So like here, what we're doing is we're kind of like when we're calling apply move, right? To actually like execute this function, like the interpreter or whatever, the JS runtime is first going to have to like kind of compute a game state.clone. So it first copies everything into a new game state. So this is like a fresh, different thing. So it's like new board. So like let's just kind of like write a game state as a linked list, right? Kind of like this. Like this will be like GS. And like it has a back pointer to like a previous game state and so forth, right? So then what we're doing when we're actually calling when we're calling apply move, what we're doing is we're taking this GS and then we're gonna clone it. So that clone again kind of like has that. And then we're gonna take, so now we have like kind of a clone of everything. Right? This is like GS copy. This is a clone of GS. So technically like they're both GS. This is like GS clone. Right? This is the clone. And then when we call apply move on this game state object, then on move to play, like we just apply the move, we're basically kind of taking this object and then like, I'll write this is GS clone, GS copy, right? And then what's happening to this game state, if this is like let's say like A, if this is like A, and then that's like B, and that's like C, then like this thing kind of like by copying, we get the C. But then once we call apply move, what's happening is this C becomes a D, and then this pointer, like which points to B, it gets deleted. I mean, rather than pointing to B, we're now in apply move. What apply move does is this argument here, it sets it as like the next prev. So now the back pointer points to that. So now at the end of this, once this function is finished, like how does our universe look? Like what is GS at the end of all these operations? Well, it should look like this, just like it was before, except ABC becomes ABCD. So GS would now be D, right? And its previous is pointing to C. And then C's previous points to B, and so forth. And then B to A link has never been actually it's never really been contested. Just yeah. So net effect is from ABC, we now have ABCD, like after all that. And note that because of the whole cloning process, these are all kind of like new objects. Like these are all distinct objects. Whereas in Connect 4, when you took the game state and you applied the move, you only had one game state object in terms of self-play. Like in the examples, yes, we're by convention, we're always cloning it. But yeah. So yeah, I think this looks good. Okay, let's just quit that. Get status, get diff. So then these get diffs are just we're just kind of like adding in what we have to backpoint to. So that's fine. So in this case, like I said, in this case next, like in this case we just clone the game state directly in like right here. But then here you might say, hey, like why aren't we doing the clone, right? Well, this next game state is the clone, right? So like there is going to be a clone somewhere. Like we are going to create new objects for game states. Like that's a given. Like in the Monte Carlo tree search, like the MC node has a member of the game state. In that game state, like between two nodes, different nodes have to have like different game states, like different objects. They can't like point to the same game state. That's just wrong. I mean, unless you're talking about transposition tables or whatever, like if you kind of like, I already talked about this, we're not worrying about that. But like we could like hash the game state and then, but it's a bit too complicated, so I don't think it's a good idea. Like different move orders can result in the exact same game state. That's called transposition. But anyways, so here's your get diff. We're just kind of like adding in this new this new game state as our second argument. So I think that's all. Get add all, get status. Okay, now let's just make sure it compiles. Okay, it compiles. So now, in theory, if everything is done correctly, then all you have to do is run node train.js and like wait like a week or an hour or like wait a long time and then like get some results. So like in theory, we're done. Now it's time to, I guess, I mean, what should I do now? Let me actually I want to do some like using Scratchpad, right? Like we have like I created the scratchpad.ts file. So actually I think it's a good time to actually like test out, because like ultimately like what kind of like two things that kind of like concern me the most are net.ts, like the actual neural network, and then symmetries, which we did. Like we did a whole bunch of work like past two streams. Well, technically I think past three, but then the first stream was more like a broad overview. And then like the past two we actually implemented stuff. So I really want to test out net.ts and symmetry.ts before actually I want to like do some debugging, like stepping through and like breakpoints or like maybe in Visual Studio Code or something, VS Code, in user Scratchpad. So in fact, let's actually like kind of open up. Let's start off with net.ts. Like one thing which is untested is the actual like the thing where we actually like take our neural net and like take a game state, and like yes, we have double checked like the game state representation by discretization at length. Like we've covered that pretty well. I'm pretty confident on that. But then the actual output that we get, like when we kind of build a policy from that, like in theory looks good. But I want to like see it like actually kind of work, right? So let's just kind of open up our scratchpad.ts and our net.ts, right? Let's just kind of yeah, let's kind of go to the next one. Okay. First things first, let's import net from net. Just like that. And then let's import the game state. No, let's just import let's import the game state. Let's kind of import. Let's import everything. Just for good measure, actually. Just a bunch of imports, doesn't do anyone any harm. And then what should we do? Let's create let game state equals to new game state. And then let's actually like get a policy from the game state, right? Just like MCTS create node does, right? Actually, let me just I want to basically call this function get policy and value. In fact, let me just kind of open up mcts.ts as well, right? Get policy. It's going to be in the create node function, right? So like in the create node function, what we're doing right here in create node, right? In this create node function is like we're kind of calling get policy and value. Again, we talk about this whole symmetry stuff. We're just kind of like, yeah. Get policy and value from net. Okay, so I think rather than like kind of like importing net, I think we should like do that, right? Get policy and value from net. I know this is MCTS search. Well, yeah, it is. So we just kind of called that on the game state. Oh, right. The policy and value for game state. Or yeah, just policy and value equals get policy and value of what? The game state and the model. Wait, where's the model? How'd the model come to be? So this takes in a model. So I think the model is created in train.ts, right? just like this. Policy equal to that of 0. And in fact, let's just convert this back to tensor too, for good measure, right? Like, let's search for export, like whatever kind of public APIs that we're kind of exposing, like this type example, or like, well, const, no, it's not, the functions. Well, create image that we've already debugged. So let's get policy and value in this export. So then we're going to test that out. And then this whole train model. I kind of want to export this convert policy to tensor thing too, just to test it out. Or you know what, for now I think I'm satisfied with what we've done. Get status. So again, like Scratchpad is not in our is in our get ignore, so it's not going to show up as in our get status because we're ignoring that. So let's like do the same TSC whatever, but let's do it on Scratchpad. Okay, there is a problem. Hang on. Okay. All right. So, oh wait. So just wrap it like that. TS. Sync function. Do work. Let's call it stuff. That sounds very precise. Just like this. Okay, so Scratchpad is now has been compiled to JS. Now let's actually open up VS Code. So our Scratchpad. Oh wait, where's our TS config? Because we need the source maps, right? TSC source map flag. Okay, so source map true. Okay, so then what we want to do here, we want to open up a console. So then true, TSC source map true. Oh wait. Scratchpad.ts. Okay, let's look at a scratch map or scratch pad. Okay, fine. So now we have source map. So now scratchpad. In fact, let's just have like source map true of everything.ts. Or actually no, of MC or train.ts. Or actually wait, hold on. Get status. Let's delete all the CF files, right? So rm net cf.ts. Or wait, no. So now we have like map file for wind. Yeah, we have. Okay, no, never mind. So by doing this for train.ts, we get source maps for like everything else basically. That's like the wind, the coin, whatever, right? Like, yeah, we have a coin map file. Okay, so now, well, let's go back to our scratch pad. Let's set a breakpoint like let's set a breakpoint here, and let's try running this somehow or debugging it. Run debug, debugger. Let's just do Node.js. Okay, so then we're basically calling Node on scratchpad.js, and we hit it, right? Okay, good. So now let's see our game state. Let's kind of step over that to create a game state. And now let's look at our game state. So our game state has 6 coins, and it has a game board. Game state. Game state. So we can kind of like use this console too, which is pretty cool, right? So game board, no, we already know that. So then we have the coins, right? Wait, what? Let's just make this a bit bigger, maybe. Let's make this a bit smaller. Or no, that's fine. Okay, so now let's step into get policy and value, right? Let's just step into that. Okay. I hate how like this thing is covering up the name of the tab, but we know that this is that this file is actually let me delete the map file. Delete this. Close that. Close that. Close that. I wish I could like take this and like kind of, oh, you can. Okay. So now we're net.ts, right? So now let's actually look at the let's actually step into the input. Just actually no, let's skip over that. So now we have the input. So now this is our input, right? Float 32. Shape 1, 15, 29. So this is the shape, right? So 1 basically means like the number of like the outermost dimension, like the batch size or like number of for n, NCHW. So that's n, and then this is h, the height is 15 rows, then the width, so n, and then h, w, and then c, number of channels is 9, right? 9 because we have like 4 times 2 plus 1. Like 1 is for obstacles, and then 2 times like 2 is like the number of like coins like play like the like we have like both the game state and the pre-game state. Therefore we have a factor of 2, and the factor of 4 is because like a game state like the coins in a game state, take 4 image planes, namely current players king coin, current players non-king coins, non-current players king coin, non-current players non-king coins. So that's why it's four planes there. Okay. So yes, you can just multiply all these numbers to get the actual size, right? So then like 15 times 20 is 300 times 9. Well, 9 times 3 is 27, then 100. So this checks out. Okay, so now okay, so then we have our input as a tensor. I mean, so then we're going to kind of call it in the model. Now, for the first time, I'm going to see what the prediction actually looks like, right? So let's see what the prediction looks like. So it's a tensor with 2 things, right? Actually, this looks a bit weird to me. Shouldn't the prediction be an array? Like an array, like a singleton array? Like for the, oh yeah, I guess because it's singleton, it just unboxes it for us? I don't know. Never mind. Okay, so then there's 0 and 1. 1 is policy, 1 is value. So I'm guessing policy is the 0, the first one. Let's look at the value first. The value it says is what? Well, we actually that's the data. Yeah, let's just do that. Policy data of 1.print. Can we do that? Sorry, prediction of 1.print. So basically 0.008. So the value data is quite close to being a draw. Value data 0.008, and then what's the policy data? Policy data is a huge thing of size 2400, the actual policy, right? So like the first 3 basically correspond to the image direction move ID 0. Next 3 correspond to move ID 1, so like 45 degrees and so forth, right? So now let's actually kind of like look at how it's building how it is building the policy from the policy data, like based on the coin coordinates. So okay, so now we're kind of getting the coin for the current player, and is P1 turn is true. So we're getting like P1's coins, right? So all P1's coins. So okay, here's the first coin. The first coin is this one right here, right? And this is not the king. This is just some coin. That's not a king coin. So okay, fair enough. Now let's look at its coordinates, right? 4, 2. So let's kind of go back to our whatever that Reddit thing was. So let's close this, close that, close that, close. Okay, let's just yeah, here it is. Stop. So 0, 1, 2, 3, 4, and then 0, 1, 2. Wait, 0, 1, 2, 3, 4, 0, 1, 2. Yeah, I shifted this one here. So okay, so basically we're talking about this coin, except it's a bit here. So this is the coin we're talking about, and its coordinates are 4, 2. Okay. So now let's so now from move ID 0, what's the move velocity? The move velocity is what? It's some x component and 0 y component, which is correct, right? Yeah, that's correct. And then basically we're generating a move by taking the coin ID and then the move ID of 0 and then move velocities, right? Just like that. In fact, let me go to the constructor of move, or let me kind of go to this one. So okay, so it's first Vx and then Vy. And I believe that's what we're doing, right? Move velocity of 0, move velocity of 1. Let's get move velocity again, just to refresh myself. Yeah. Vx and Vy, or get move velocity, returns the form Bx, Vy. So always X is first and then Y for velocity at least. So that's correct. X and then Y, we just saw that. Let me just double check that again. Yeah, first X, then Y, Vx, Vy, that's correct. Okay, so now policy data index, let's just compute this. Like the policy in this, let me just compute that, right? So then the move ID is 0, so this whole thing kind of zeroes out. We're in the first batch of 300. Like there's no offset there's no directional offset. And then the number of columns, like 4 2, right? Let's just forget about this. Let's kind of compute it. So like we're here, right? So what's index is this? Well, 1, 2, 3, 4. We basically have to skip over these. So we're skipping over, each of them is a 20. So we're skipping over 80 of these cells. So 81, 82, 83. It is the 83rd, which means because of zero indexing, it has index of 82, 82nd. Let's check that. 82, that is correct. So now we kind of like take our policy data, which is an array of 2400, right? Our policy data is an array of float 32 array of 2400. Then we index into its 82nd element. And would you look at that? 0.00042. That's the probability. Now we're going to bundle it up with the move of this coin 151. If you look at our game state, our coins with a 151, that matches the first coin. It is not a king. It is player one's coin. And then its coordinates are, well, they're in fixed points. That's a bit annoying, to be honest, but it has more y than it does x. In fact, it has like roughly double, right? 4.2 or something. There's a 0.5, I think. Or wait, no, never mind. It's not going to be double because it's like the 0.5s. It's just not going to be like directly double. Okay, that's fine. That's all right. So yeah, so this looks good. So let's just kind of step out of this function. So now we have the policy and the value. So let's the value I know is like about to draw, and then here's a policy. So stop. Okay, so the array is 24. Why 24? Wait, why 24? Oh yeah, okay, fine. 24 is correct because for player one, right? For player one, has 3 coins, right? Like 1, 2, 3. And each one of them can be launched in any 8 directions. So 3 times 8 is 24. So that checks out. So let's actually look at the policy, right? Like policy and value of the 0th one was actually the policy. Is a list of moves and probabilities, 24 of them. So as we can see here, it's like 0.41, 0.42, 0.41, 0.415. So they're all like generally kind of roughly equivalent. So right now it's like kind of a uniform distribution-ish. And let's like kind of like check like the first. So it's like coin ID is 151D8. That's familiar, right? We just saw that coin. 151D8. 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 So now we've seen from 0 through 7, 151D8. So that exhausts all the moves for this coin, right? So now 8, let's predict. What coin might this be? Either this or this. Let's find out. So 8 has FA28. FA289. And which coin is that? That's D. Wait, what? Do you have a bug? So the 8th one, coin ID FA289. Not this one. Oh yeah, FA289. Okay, so this is the king coin, and that's still player one. So then basically, the next 8 are going to be for this coin, right? So from 8 is this coin all the way to what? 15, right? 8, 9, 10, 11, 12, 13, 14, 15. That's 8, right? So we got F828 all the way there. Anyone in between is going to be F8, yeah, again. All of them in between are also FA289. Yep, they're all FA289. That's from 15. And then the next coin, all the way from 16 to 23, should be for whatever this coin ID is, D613. So let's check that. D613. From what, 15 to 16 to 23? 16, 17, 18, 19, 20, 21, 22, 23. So like so 16 is, yes, D613, which is the same as this one. Okay, this is very annoying. Let's just actually write it out. Probabilities from 16 to 20 is D something, yeah, D613. Again, 15 is not, it's the other one, right? Exactly. So it's D613, the last one, D613, then D613, 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 D613. So like we've checked to make sure that each coin from the first three, all player one's 3 coins have 8 moves, right? And they all have roughly the same probability, right? So I think, so this looks good. So now we have a policy. Let's step out of this function. Oh, and that's it. Scratchpad ends. Okay. So right now we have just kind of like, we've kind of tested out the get policy and value, or we've seen it in action. We've like taken our network and like kind of got our neural net past the initial game state and got a policy that like seemed to be uniform, but yeah, like clearly something's happening. So this looks good. I guess the next thing to do might be to like test symmetries, maybe, to make sure that like stuff looks good. Maybe applying move, or like I did some stuff in net.ts where I kind of applied a move and like looked at the representation change. Maybe test out cloning, like clone a game state, make some changes to the clone, and verify those changes don't get propagated to game state. Or what we can do is actually like start running the training and like kind of personally I feel I'm going to stop for now. This will be really short. We're just kind of like getting ourselves familiar with like debugging on VS Code, I guess. But I mean, I could just start training and like kind of stepping through the tree search and everything. Or should I do like some more work on Scratchpad? Like test, like just try some more stuff and like step through it and like just kind of watch all my, like step through all my new BumperCoin specific logic code and like kind of just test everything out? Or should I just like kind of like, well, I think the next thing is like kind of let's maybe test out some symmetries, and then among possibly other things, if some more stuff comes to mind to me later, and then maybe just start training. So yeah, so I think like things are going pretty well. Like, so yeah, I think I'm just gonna stop for now. Guess this one was pretty short, but yeah, that's fine. Later.